The problem is I can hear my voice. That's too ugly for me. Hello. No, I can't hear anything, but it's fine. If you can hear me, that's fine. Okay. Right. So I'm Keshan. I used to work at Google as the country engineering consultant for Sri Lanka. Currently, I'm from Sri Lanka, so I'm here in Sri Lanka. And if you don't know what Sri Lanka is, it's a country. It's an island country, just 30 kilometers south of India. And to make you guys jealous, we have sun for all the 365 days. So we have summer for all throughout the year. I'm not going to introduce myself in detail. Let's just get into the action soon because I think it's pretty late here. It's almost 2 a.m. So I was going to talk about, give you a brief about TensorFlow and deep learning because I think since you guys are familiar with computer science or IT related, since you are from that background, I think you have heard of TensorFlow, deep learning, machine learning in the last few years, unless you were, of course, in a coma or any unconscious state, right? So I thought of giving an introduction to something that, not many people are talking about, like some of the basic nuts and bolts of TensorFlow, right? So I think if you just try to understand TensorFlow, sometimes you just build a model, maybe use a high-level API like Keras or estimators, but not many people. Since you guys are more into computer science things, I guess it's better to have a knowledge in some of the basic nuts and bolts. So let me share my screen with you. So you will not see my pretty face for a while. Okay, can you see me? See the screen?
Yeah.
Hello?
Yeah.
Yes.
Can you see the screen?
Good idea.
I don't think you can see my thumb.
Okay. All right. Good. So now I can't see anyone because I can see only my screen. So if you haven't seen this tool before, this is called Google Colab, which is a Google's platform for Jupyter notebooks. So this is I'm trying to introduce this tool as well because it's a wonderful tool. If you do some experimentation or if you're trying to learn some of the concepts, machine learning concepts or data science concepts, this tool is pretty handy because it's free. You can even have free GPU or TPU resources, and you can do pretty much. Most of the stuff like experimenting or learning new concepts with machine learning. And if you have a knowledge in Jupyter Notebook, this is basically the same things, right? And the other thing is libraries like TensorFlow and all the other dependencies comes installed with this platform. So you don't need to worry about installing TensorFlow or maintaining the dependencies or anything like that. So which is pretty easy for us to work on, right? So today I'm going to talk about graphs and sessions in TensorFlow, right? I would like, if you ask any questions, if there's anything unclear, I would like to get your questions once I'm doing this because I have no idea about your background or what your knowledge level with TensorFlow. So I'm trying to tell everything as I feel. But if there's anything that you need any clarification, please go ahead and ask at any time. Right. So TensorFlow is a kind of what we do is we first create a graph. Okay. Graph is graph consists of nodes and edges, and usually in this computation graph, the edges which represent the computations or the operations for a particular task. And these edges will carry the data, usually the tensors, right? So tensor is something you can visualize it as multi-dimensional array. But if you're from maybe a mathematics or a physics background, probably you might have a slightly different definition. But here, for our purpose, we can simply think it as a multi-dimensional array. Okay, so these edges will carry the data or the tensors from this node to node. So one node can do a different one single computation. For example, it can do a matrix multiplication or adding two numbers, right? So after every computation, it will send the tensor, the product or the computed result from through this edge to the next node, right? So that's why it's called a TensorFlow. It's a flow of tensors from node to node. Okay. So in TensorFlow, what we first do is we first create the graph. We first create this computation graph, like what is the input and what are the computations that we need to do for each input and how it connects with each other. So that is the basic idea of that computation graph. And after we create that graph, then only we run the computation. Run the computation graph, execute the graph. So I can show you, like, let's start running these things. So we first need to import TensorFlow, of course, and then let's see what happens here. So usually in normal Python, if you do this, like hello world or something, if you print this, you can see hello world, right? What happens with this TensorFlow thing? You can't see the output like hello world. We have a constant called which is with the value is hello world and which is assigned to a, but when you print it, you don't see this output. Why? Because we have only created the graph, right? But in order to get the output, we need to execute that graph. So to do that, we use something called session. So inside the session, we can run the graph. When we do that, that's where it will execute it. It will be executed, right? So you can see it. We can see the output. We have created the graph here, and then we have created a session, and then run the session inside that. Run the graph inside that session. Okay, cool. Right. So why we use this kind of? Why TensorFlow use this kind of paradigm? This kind of a data flow paradigm? There are a few reasons. One thing is that it can distribute the web, because when you create the graph, you can easily distribute. With the power of GCP or any other cloud provider solutions, you can distribute the computation to different computers and make it more faster. And the other one is like portability. You can simply get that graph and port it to a different device, maybe, or different architecture, maybe from CPU to GPU. So there are so many things that you can do with this kind of a graph. But from TensorFlow, I think the next major release, they are going to introduce more dynamic approach, because really experimental. If you're doing experiment, this is pretty hectic. You need to create graphs. You need to execute a graph every time. So it's pretty hectic for experiment. So they are going to introduce some dynamic operation. It's still we have. TensorFlow already have something called execution. You can use that execution to reduce this execution part. To the static part, but and add the dynamism to your computation graph. But they are going to make it by having that dynamism by default from the next major release. Okay, so is there any questions up to now? Can I go ahead?
Yeah, we're good.
Yeah, good. That would.
Okay, sure. So let's do a simple calculation. So this one is, everybody knows pi r squared, which is to calculate the area of a circle, right? So to do that, first we can define pi and r. So r here you can see two different things. Like pi is a constant, everybody knows that. So placeholder is where you can feed your inputs later on. So R is the placeholder for this thing, right? Then what we do here is we simply write our graph and all this to a file where you can read it later on by tools like TensorBoard. So TensorBoard is a tool where you can visualize so many stuff like the graph, or maybe if you're training a neural network, you can see how it's training and what are the accuracy levels and different other metrics through that visualization tool. So which is one of the easiest or the best visualization tools available in today for visualizing your neural network training and getting an idea about how it's working and what are the problems and how to debug your models. So usually you put this thing into your logs folder, but since I'm on Google Colab, this is the part that it will, the TensorBoard will look for the file. So I'm going to save all this data into this graph directory. Right. So this part is only for Google Colab. If you're running this code in your laptop or in somewhere else, you might not need to do this because this is just for the Google Colab. Right. So we are going to run the TensorBoard where you can visualize the data that's given here. Right. So if you go here, right, it's not there yet because we see. Okay. That's not there yet. Okay. I'm going to reset the runtime again because sometimes because I ran it before, probably. You can make sure you have GPU. So in the meantime, if there's any question, would be fine to answer. Right. Even here, we have just created our graph, and then we are running this graph inside a session with something called feed it, where we can give one or maybe several other inputs to feed into this R. That means it will first try to feed number 5 here and give the answer as y, like when r is 5. Likewise, like for all the other inputs, it's going to give you the answer. Let's see. Okay. I'm not sure what's happening here. Okay, let's run a normal neural network. So this is a basic neural network. It's a 3-layer neural network where you have input x, and you have the weight biases for all the 3 layers. We have just defined them, and these are activation functions. So what you need to know is, if you have no idea about neural networks, just that's fine. I just wanted to let you know, like these extremes input, which is a tensor, and all these are tensors, and this one is an operation or a computation where you multiply 2 matrices and then add one matrix, right, or a tensor. So similarly, then the graph will like go on from first layer then to the second layer. There you have 2 more two more tensors, and then you have another computation. So when you run this graph, you will get a graph something similar with this. You have x and w1. You multiply these 2, and then the next one, the product of these 2 goes to the addition, and it will be added with the bias or the b1. We got the idea. So this is a basic neural network. Let's see why this is not working. Okay, here it goes. So we have the neural network that we created here. And you can see the computation graph with all the computations and all the tensors here. Right? So this is the basic thing, but now the thing is, like, if you're using KRS or estimators or any other high-level APIs that more frequently used by different people, you might not need to understand this stuff, the sessions and graphs. But if you want to improve your model, or if you want to do more research into these kind of new architectures, this might become handy for you to know the underlying workings. It's like the engine of your car, so you don't need to know the combustion engine to know to drive a car. But if you know that, you can do much more amazing things. So this is pretty much it from. I thought it's a lightning talk, so that's why I came up with this small thing.
That's perfect.
But if you have any questions, feel free to ask.
Maybe we have to clap extra loud for him so he can hear us.